Therefore, you can see with that little bit of counterintuitive knowledge, you now know why consensus blockchains can't scale, but also why they can fool themselves into thinking they can. Hello, I'm Paul Dowding, and in today's video, I'm going to talk about why blockchains can't scale computationally because of consensus. Within a consensus algorithm, the nodes have to validate and vote on all the transactions and blocks that are distributed throughout the network. It's really the counting of the votes with the validation of the encrypted signatures that expands exponentially from a computational perspective. And I'll show you with a simple example. So imagine a series of nodes that each generate 10 transactions each. However, this may be more easily understood if we go to a whiteboard. So recreating my real life example, where 5 nodes create 10 transactions each, they have to create and sign their own transactions. They then have to validate and vote on the other nodes' transactions. And lastly, verify and count all the votes from all the other nodes. With these activities, let's consider the number of nodes, the number of transactions, and then the total computations per node. With the first example of 2 nodes, there are 20 transactions. 10 are created and signed by each node. They validate and vote on the other node's transactions, and they verify and count the votes from that node, leaving a simple total of 30 computations per node. With 3 nodes, there are 30 transactions. Each node has to create and sign its own 10 and validate and vote on the 20 transactions from the other nodes. But now this means every node has to verify and count 40 votes, which totals 70 computations. With 4 nodes, there are now 40 transactions. Each node creates and signs its 10 and has to validate and vote on 30 transactions. But this means it has to verify and count 90 votes, which leaves a total computations of 130. If the network expands to 5 nodes, there are 50 transactions. Again, create and sign 10, validate and vote 40, but have to verify and count 4 times 40 votes, which is 160. Now the total computations are 210. So what we see is that as the transactions increase linearly, i.e. at the same amount for each increase in node, the total computations are expanding exponentially at an accelerating pace. So let's graph this to demonstrate it visually. There are the number of network transactions and the computations per node on the y-axis and the number of nodes on the x-axis. The total number of network transactions increases from 20 to 50 as a straight line. It's a linear progression. The computations per node, however, expand exponentially. 30 with 2 nodes, 70 with 3 nodes, 130 with 4 nodes, and 210 with 5 nodes. You can see the acceleration of the line upwards. And that ends our whiteboard session. So you can see from this, the blockchains with consensus algorithms cannot scale. And this is because as the number of nodes increase, the number of votes to count increase, and they're multiplied together, and they increase exponentially. Some solutions try to break it up by breaking their blockchains into shards or channels or clusters. But think about it, if you have to break something up to help it scale, you are by definition proving that it can't scale. The interesting fact, though, is that if you keep the number of nodes the same and just increase the vote by nodes, that actually scales linearly. And therefore, the nodes can fool themselves into thinking that they can scale. The reason for this is one of the factors, the nodes times the number of votes stays constant. So as the votes go up, that's the only multiplier, and that's a linear expansion. And if you look at a lot of the white papers, they often have very small implementations of 4 or 5 nodes, and they measure their performance by increasing the votes per node, but not actually increasing the number of nodes, which means when they get out to be implemented in the real world and they're spread amongst 50 nodes instead of 5, they find themselves performing much slower. Therefore, you can see with that little bit of counterintuitive knowledge, you now know why consensus blockchains can't scale, but also why they can fool themselves into thinking they can. Well, I hope this video has proved useful to you, and you now understand why consensus algorithms in any form cannot scale. If you have any questions or comments, please leave them in the comments below. Thank you again for watching.